Hi viewers, welcome to LMS Solution. Today we are going to see about adaptive PSO MPPT algorithm for solar PV system with the partial shading effect. So what's the difference between conventional PSO and the adaptive PSO? I will explain here. This is an adaptive PSO MPPT port for solar PV system. Here you can see that this is the normal adaptive PSO code here. A normal PSO or conventional PSO, the value of inertia and then C1, C2 always constant in conventional or traditional PSO BPT. But in this BPT, I'm going to vary the NHA value and C1 CT value based upon a different parameter. First, I'm going to explain the inertia value going to be vary based upon the particle test and the average fitness of the each iteration. Here you can see that we are going to compare the particle first value with the average fitness value. If particle rest is greater than average fitness, then the W going to be taken the maximum value 0.1. If suppose the particle waste is less than or equal to average fitness, then you have to calculate the inertia based upon this equation. So W which is equal to W max minus W minimum multiplied with the population waste minus minimum fitness of that particular iteration divided by average fitness minus minimum fitness. If the condition that means particle waste is less than or equal to minimum under an average fitness, then you have to calculate the inertia by using this formula. If suppose if both conditions not true, then inertia we are going to take which is equal to 0.05. This is a variation of inertia with respect to every iteration. It going to be vary every iteration. It will be affected. That means it going to be vary that the velocity updation true for every iteration. And also here you can see that we are having parameter one is C1 C2 and then that means personal learning and the global learning coefficient. So the C1 C2 here going to be updated every iteration based upon this formula. We are here considered as 1.3 plus 1.2 the cost of 5 into A divided by 4. 4 here is the total number of iteration I consider. Number of iteration for finding the maximum global point or global duty cycle here is considered as 4 iteration. K nothing but iteration count. That means every iteration count. Based upon this value, C1, C2 also going to be this parameter inertia and the C1, C2 parameter going to be just the velocity function equation. So every iteration that velocity will be updated based upon that inertia C1, C2 and then population first and then global best value. This is the difference between normal adaptive PSO. So it will be adapted according with that value of C1, C2. This is known as adaptive PSO MPP for a solar system. Here in normal PSO, WC1, C2 always constant. Here the WC1, C2 will be vary every iteration. You have to find the global duty cycle for the solar PV system. This is the code we are implemented for adaptive PSO MPPT algorithm. And I'm going to explain the model now. This is the model we are developed for testing that adaptive particle sum optimization MPPT for solar PV system. So this PV panel consists of 4 cells, PV cell 1, 2, 3, 4, and each cell having the maximum power of 62 watts. And then here you can see that this is a voltage at maximum 4.30.96 and 1 by 4. That means the value around 2.74 volt. That means maximum point is around 7.74 volt, and then the current at maximum power point is 8.07. Here you can see that here 7.74. So here you have 4 panel series. 7.74 into 2, which is equal to 30.96. When the normal standard testing condition, the voltage across that panel is around 30.96. Current from that panel is around 8.07. Here, this P panel connected in series, not to here we are measuring that the current from that 4 PV panel, and then we are measuring voltage across that 4 PV panel. That is going to be given to the input for that adaptive PSO VPT. Here instead we are calculating the duty cycle here based upon this velocity updation equation. That means randomly we are generating the duty cycle initially, and then is sent to that corresponding model, and then every duty cycle it updates the voltage and current. By using that voltage and current, we are calculating the power for every duty cycle sense from adaptive PSO MPPT. We are calculating the power. That power going to be stored as particle burst. That means per particular iteration it stored as particle burst. And then based upon that, after First iteration, we want to find out the population based and global base, and then going for iteration. Iteration will be taken here. Iteration will be start from here for global plus base, and then population base. We have to update the velocity, and then you have to update the duty cycle by using this functions. After some iteration, what happen? It will be adaptive PSO will be generate the global duty cycle after extract the maximum power from the PV panel. Now I'm going to explain the system. Here you can see that this is boost converter is connected in between the load and the PV panel. First I'm going to set the irradiation of all panel which is equal to 1000. Right? Here the panel rating is 62.46. 62.46 into 4 is around 240 and 250 watts. Maximum power can be attained at the standard test condition is 250 watts. So here I'm going to fix the irradiation of the out panel equal to 1000, and now I'm going to simulate the model, and then you have to check the results. This is variation of PV voltage and the load voltage. This is variation of duty cycle. This is a PV power and load power. Here you can see that after a 0.2 second, the maximum power extracted from the PV panel by means of adaptive PSO MPPT for the uniform irradiation. Here, the four panel having same irradiation. So now I'm going to change the irradiation level. For example, I'm going to change the irradiation of second panel equal to 800. We will check this results of the adaptive PSO MPPT. Here you can see that now also we are getting the maximum power. So this is the duty cycle generated from the adaptive. Here you can see that we are getting around 205 watts power from the PV panel. This is a PV voltage, and then this is load voltage. This duty cycle from the adaptive PSO MPPT. This is PV power, and this is load power. So next time I'm going to change the irradiation of the port panel equal to 800. Again, we have to check the results. Now also we are getting the maximum power from the PV panel. Now we need to check the system with its dynamic changing irradiation. For that, I'm going to change. That means I'm going to fix the irradiation for the panel 1 to 3 is 1000, and 4 panel is I'm going to fix as also 1000. After some time, you need to change the second panel irradiation from 1000 to 800 watts per meter square, and then we will check the results. Now the maximum power extracted from the PV panel. At the time of 1 second, I'm going to change the irradiation of the second panel from 1000 to 800 watts per meter square. Now we will check the results. For change in irradiation condition also, we are getting the maximum power from the PV panel because of the adaptive MPPT algorithm. This is a working of adaptive PSO MPPT algorithm for solar PV system under uniform and partial shading condition. Thank you. Thank you so much for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much.